Today we're going to talk through section 2 of chapter 5. We're going to introduce the 6 basic trig functions that we're going to be working with, and we're taking a unit circle approach starting in this book. We've already introduced the unit circle and our quadrantal angles. Remember, the quadrantal angles fall on the quadrants. So on our x, y axes, we have our quadrantal angles. We start here at 0 degrees or 0 radians. This positive y-axis is at 90 degrees. Over here we have 180 degrees. Another 90-degree rotation takes us to 270 degrees. And then a full rotation is 360 degrees. Let's think about what this means in radians. Well, 0 degrees is also 0 radians. Halfway around, 180 degrees is equivalent to pi radians. So halfway between that, 90 degrees would be at pi half. So we have 1 pi half, 2 pi halves, 3 pi halves, and then 4 pi halves is the same as 2 pi radians. That's how we walk around our unit circle. Well, if we're on the unit circle, that means that our radius is 1. So this location is 1, 0, because it's 1 on the x-axis, 0 on the y-axis. This location, therefore, is going to be 0, 1, and then we come around to -1, 0, and 0, -1 as the coordinates where our circle intersects our axes, if our circle is the unit circle with a radius of 1. So let's talk about these as point P. If theta is 180 degrees, then the coordinates for this point are -1, 0. Go ahead and fill in the rest of these. Be sure to pause the video if you need to as you're referencing your unit circle or the sketch. And think about why each of these fits. Okay, so trig gives us the words sine and cosine to describe the relationship between the angle and the point on the unit circle. Keep in mind that any variable, in this case t, can be used to denote the angle measure. So as I'm being given these definitions, t represents the angle instead of theta or alpha or any other Greek symbol, Greek letter. T, that angle measure, is what we call the argument. When you are writing things for your trig functions, make sure that you don't skip that argument. You have to reference the angle. Well, you can't just write something as cosine sine. It has to be cosine t sine t or cosine theta sine theta. You have to have the angle represented. Okay, so the sine function, denoted sine t, associates each angle t with the vertical coordinate, that is the y coordinate, of the point P that is specified by that angle on the circumference of a unit circle. And the cosine function, cosine of t, associates our coordinate to the x coordinate on our unit circle. Therefore, point P has the coordinate pair xy, which is the same thing as cosine t sine t. So cosine coordinates to our x coordinate, and sine coordinates to our y coordinate. Knowing this relationship, using a calculator, set in the correct mode, degree or radian, verify the answer found in part 1. So we're going to have to pay attention to the mode of our calculator. If I'm using an angle that's given in degrees, I want it in degree mode. If I'm using it for an angle that's given in radians, I want it in radian mode. Well, where is my mode option? My mode option is right here. If I push this degree button, you can see I'm in degree mode. Radian mode is right next to it. We're not going to use this third option. We're just going to be doing degrees or radians. My first problem is in degrees, so I'm in degree mode, so that's great. I'm going to clear that out, get out of that. I want to know the sine function value at 180 degrees. Well, sine corresponds to the y-coordinate, and at 180 degrees, my y-coordinate is 0. So let's do that. Let's do sine of 180, and I'm in degree mode. My calculator screen tells me right there I'm in degree mode, and that is 0. Yep, that's what I expected it to be, so we're doing well. Now, cosine pi. Well, cosine corresponds to the x-coordinate. Pi is the same as 180, but we want to make sure we know how to input radians into our calculator. So we're going to find cosine of pi. We expect it to be -1. If I push enter, it does not give me -1. Well, why not? Well, because I didn't change my mode. So I'm going to go in, I'm going to push degree and move over and change the mode and hit enter. So now I'm in radian mode. And if I hit enter again, it finds the correct value because now I'm in radian mode. So cosine at pi is -1. Let's do sine of 360 degrees. 360 is over here. The sine function value here is 0. So let's switch back to my degree mode. Let me get out of that glare. Switch back to my degree mode and do sine of 360. I'm in degrees. Enter is 0. That's what I expected. And then it asks me to find the cosine function value of 2 pi. So cosine of 2 pi, and 2 pi is given in radians, so I need to switch. That gives me a +1. That's correct. Over here, my coordinates are 1, 0. Cosine is the x-coordinate. Now, each of these trig functions, my 6 trig functions, correspond to the length of a segment that is associated with my circle. The cosine is the x segment that is 1 unit long. The sine corresponds to this y segment, and it hasn't moved off the x-axis, so it is 0 units long. When I rotate around here, I have 0, 1, because my cosine length, if I'm going directly up, I haven't moved over. That cosine segment would be 0 units, but the sine segment is the length of the radius, 1 unit. All right, we need to answer the rest of these problems. I'm going to encourage you to pause the video, answer these, and then come back to me. So you don't have to switch back and forth from radian to degree. You could do all the radians and then go back and do all the degrees. Remember that you're looking for those coordinate values where sine corresponds to the y-coordinate, cosine corresponds to the x-coordinate. When you have completed that and you have gotten the calculator to give you the correct answers, now this is an emphasis here to make sure that you can use your calculator correctly. You figured out how to give your calculator to give you the correct answers that match up with the information that you know to be true. Let's go ahead and move to the next page. On this next page, we're going to go ahead and define the remaining 4 trig functions. From the definitions of sine and cosine, we derive the rest of them: tangent, cotangent, secant, and cosecant. Let t be a real number, so that's our argument. It's going to be t. P, a point, b, have coordinates x, y on the unit circle that corresponds to that location. So as long as x is not 0, the tangent function associated with t is the ratio of the 2 coordinates, y over x, which is going to be the same thing as sine of t over cosine of t. Now, tangent and cotangent are cofunctions. They are also reciprocal functions. The reciprocal of y over x is x over y. So cotangent is also equal to cosine t over sine t. Those are reciprocal pairs. In fact, I'm going to write that out here. It is the reciprocal of tangent t. Then we have cosecant. Let's talk about cosecant. Oh, before we do that, let's look at this piece of information. Notice that changes. It says as long as x is not 0, that's because for tangent t, x is my denominator. Division by 0 is undefined. So the tangent function of t is undefined where x is 0. When I flip that, x is no longer in the denominator. Now y is in the denominator. So cotangent is undefined when y is 0. This piece of information is important because it tells you what is going to be in your denominator. Now, cosecant is the reciprocal of sine. Cosecant is the reciprocal of our sine function. Sine, let me go ahead and write that out here. Reciprocal of sine t. Now, sine of t is y. So the reciprocal of that, cosecant, is going to be 1 over y, or 1 over sine t, which means I am undefined if y is 0. And then finally, secant is the reciprocal function of cosine, which is x. So secant is going to be defined as 1 over x. Therefore, it's undefined where x is 0, which is the same thing as 1 over cosine t. So we have 3 pairs of reciprocal functions. Tangent and cotangent are reciprocals. Cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. Now notice that the C pairs with the S. That's how I remember this. Cosecant pairs with sine, secant pairs with cosine. Okay, let's find our 6 trig functions based off of some given information. We're given point coordinates for P, coordinates for point P. Let T be a real number that has these coordinates, and that is a point on the unit circle that corresponds to T, where T is, because we're on the unit circle, T is either the radius or the arc length. So, or excuse me, not the radius, the arc length. The radius is 1. So find the values of the following. Now, my coordinates, when I'm on the unit circle, my coordinates correspond to cosine t, sine t. So cosine t right here is negative 1/5, and sine t is 2 square root 6 over 5. Now, where would this be on the unit circle? What's that unit circle going to look like? Let's figure that out. Okay, so let's sketch our angle. If we've got our unit circle and our coordinates we're given for P are negative 1/5, well, negative 1/5, that's going to be here, and 2 square root 6 over 5, that's going to be a positive value, so it's going to be up here somewhere, right? That means I'm going to be, if I move to the left and up, I'm going to be somewhere in quadrant 2. So this is a good estimation for that location. To the left 1/5, up 2 square root 6 over 5. We know that we're given cosine and sine. Now we're asked to find the other 4. Let's start by doing the reciprocals of these 2. The reciprocal of sine is cosecant, because C pairs with S. So sine has a reciprocal of cosecant. Because they're reciprocal functions, I take the reciprocal of this value. That is 5 over 2 square root 6. I never leave a radical in my denominator. I'm going to rationalize that by multiplying by a well-chosen 1, square root 6 over square root 6, which gives me 5 square root 6 over square root 6 times itself is 6. 2 times 6 is 12, and that does not simplify. Then the reciprocal of cosine is secant. So I take the reciprocal of negative 1/5. Well, that's just negative 5. And finally, I need to work out tangent and cotangent. remember that I gave tangent as sine over cosine. So sine over cosine would be 2 square root 6 over 5 over a negative 1/5. That's going to be a negative value, correct? Which makes sense because I'm in quadrant 2. If I simplify this, I would multiply by the reciprocal of the denominator. What's going to happen is those 5's are going to cancel out. Let's just show you. 2 square root 6 over 5 times a negative 5 over 1. Those 5's cancel out, and I'm left with 2 square root 6 over 1, which is just negative 2 square root 6. Now, cotangent is the reciprocal of tangent. So I could either start here and stack them the opposite way, or I could just say, you know what, I'm going to take the reciprocal of this value. So if I take the reciprocal of this value, I have a negative 1 over 2 square root 6 that I need to rationalize again, which gives me a negative square root 6 over 12. That negative disappeared. Let me move it so that it's very clear that that is a negative value. All right, let's look at our chart on the next page. Our chart on the next page, you're not ever going to be able, or not be able, you're not ever going to be asked to reproduce these charts, but they're a good way to organize the information so that you can look at it more clearly. You can see where things are undefined. To see where things are undefined, I need to consider the question, when is a value undefined? Well, it's undefined if I'm asked to do division by 0. So anything that puts 0 in the denominator is going to be a place where that function value is undefined. We're going to start by filling in this first column, converting our degree measures to radians. Refer back to your unit circle. We have all of our quadrantal angles plus those special angles in quadrant 1, but notice that I'm not asked to fill in these values for these special angles. I'm just going to give the radian value, and then the chart that I'm going to fill in is just focused on those quadrantal angles. So my quadrantal angles are 0, pi half, pi, 3 pi half, 2 pi, and then the special angles in quadrant 1, pi 6, pi 4th, and pi 3rd. Okay, now you can go back and look and reference the information on the last page, or you can pull out your unit circle that you've completed and reference those things. Remember that sine corresponds to the y coordinate and cosine corresponds to the x coordinate for each of these. At 0, sine is 0, cosine is 1. This is also true at 360 because 0 and 360, 0 and 2 pi fall at the same location on your unit circle. We're going to skip and go in here and go ahead and do 90, 180, and 270. When I move up to my 90 degree angle, now these flip. My sine function is 1 and my cosine is 0. When I rotate on around to 180 degrees or pi radians, now my sine is 0 again and cosine is negative 1. Move down to 270 degrees or 3 pi halves, my sine function is negative 1 and cosine is 0. So you can see my limits are from negative 1 to 1. Okay, tangent. Tangent places y in the denominator. So for this function, tangent is y in the numerator. Tangent places y in the numerator. I am so sorry. Tangent is y over x. Cotangent is x over y. So if tangent is y over x, I've got 0 over 1, which is just 0. When I flip that and take the reciprocal of that, 0 goes to the denominator and is undefined. For 360, it's going to be the exact same thing. What about for these others, though? Well, if I'm doing tangent here, y is 1 over 0. That's going to be undefined. And when I flip it, the value is 0. Here, y is 0 over x negative 1. That's just 0. When I flip it, it becomes undefined. Here, I've got negative 1 over 0. Anything over 0 is undefined. When I flip that, it goes back to being 0 because my 0 is in the numerator. Negative 1 is in the denominator. How about cosecant and secant? Well, cosecant is the reciprocal of which function? Cosecant is the reciprocal of sine. It's 1 over sine theta. So if sine is 0 and I put that in the denominator, cosecant is undefined. If sine is 1 and I put that in the denominator, well, 1 over 1 is just 1. If sine is 0, cosecant is undefined. If sine is negative 1, 1 over negative 1 is negative 1. Where sine is 0, 1 over 0 is undefined. And then I have secant, which is the reciprocal of cosine. So I have 1 over 0, that's undefined. Oh, excuse me. 1 over cosine. 1 over 1 is just 1. 1 over 0 here is undefined. 1 over negative 1 is negative 1. 1 over 0 is undefined. And 1 over 1 is 1. And again, we're not asked to do these last 3 rows for our angles in quadrant 1. Now let's start focusing on those special angles, specifically in quadrant 1, but we're going to know that we know that they are going to rotate all the way around my unit circle. Consider a 45-degree angle in a unit circle. Think about dropping a perpendicular line from point P on the x-axis to create a right triangle. Now, right triangles have special properties. This is our angle theta, okay? So P, if it's hard to read that, we have coordinates that are cosine of 45 degrees, sine of 45 degrees, because we're on the unit circle, radius is 1. We know that that is true. Now, when I have a right triangle, we have a special case. Our right triangle allows us to use the Pythagorean theorem. And our Pythagorean theorem tells us that for a right triangle, a squared plus b squared equals c squared, where c is the hypotenuse. Now, if I have dropped this perpendicular, I've created a right angle here, which makes this my hypotenuse, or c. So for my 45-degree angle, it's exactly in the middle, which means my x coordinate is going to be equal to my y coordinate because the length of these are going to be exactly the same. And because of the Pythagorean theorem, a could be my x, so x squared. B could be my y, so y squared. X squared plus y squared equals c squared. My radius in this case is 1, and 1 squared is just 1. Since x and y are the same, I could think of rewriting this as just x squared plus x squared. I can use substitution because x is equal to y, I can substitute in and say this x squared plus y squared would be the same thing as x squared plus x squared, and 1 squared is just 1. Well, x squared plus x squared is 2x squared. And then I've run out of room here, so I'm going to have to come up here where I have some more room. 2x squared equals 1 is the same thing as x squared equals 1/2 if I divide both sides by 2. And then I need to solve for x by taking the square root of both sides. So the square root of 1/2, square root of 1 is 1 over square root 2. Now, when we take the square root, we consider positive or negative. Well, we consider positive or negative for all cases working around our unit circle, but right now we're in quadrant 1. We know our x value is going to be positive and our y value is going to be positive. So we're just interested in the positive square root value. When I rationalize that, I get square root 2 over 2. And that is both the cosine and sine function value of my 45-degree angle. Let's go back to our next page. Cosine of 45 degrees, which is the same thing as pi fourth, is square root 2 over 2. Sine function value of that angle is the same. Okay, now let's think about a 30-degree angle. Consider a 30-degree angle on a unit circle. Again, unit circle, so I know that my radius is 1, which means this is going to be 1. If I drop that perpendicular again, I create a right triangle, and visually you can very easily see that x and y are not equal here. So we have some value for x, some value for y. We've dropped our perpendicular to create our right triangle, which means we are able to use our Pythagorean theorem again. Now, this right triangle is this right triangle. I just blew it up, moved it out of the circle, blew it up. Here's my right angle. Here's my 30-degree angle theta that we're interested in. How do I know? Notice that this is filled in as 60 degrees. How do you know that? Well, I know that it's 60 degrees because the sum of the angles in a triangle is 180 degrees. If this is 90 and this is 30, then this one has to be 60. Now, yeah, there we go. The 30 angle has to be 60 degrees. Okay, now, in order to find the length of the sides of this triangle, think about a mirror image of the triangle itself to create a larger triangle. Well, this helps us because it creates something that is equiangular. So when we have an equiangular triangle, we've got 60, 60, 60. We have an equiangular triangle, and therefore we know that it is equilateral. All the sides are the same measure if all the angles are the same size. So if this is from my unit circle so that we know this side is 1, then that means that this side is 1 and this is equal to 1. Well, if this whole thing is equal to 1, then y is going to be half of that. And that's how we find this length of side y. So we have r, my radius is 1, that was given. We just discovered that y is a half, and we need to know what x is. My Pythagorean theorem says x squared plus y squared equals r squared. X we don't know. Y is 1/2, that needs to be plus, not equals. X squared plus 1/2 squared equals 1 squared. So x squared plus 1/4 equals 1, and I subtract that to solve for x, subtract it from both sides. So I have x squared is equal to 3/4. Now how do I solve for x? I have to take the square root of both sides of that equation. I would consider plus or minus to take in all cases, but because we've started with a triangle in quadrant 1, we know we're actually just interested in that positive value right now. That yields x is equal to square root 3 over 2. I can't simplify square root of 3, but the square root of 4 is 2. So there is my x coordinate for my 30-degree triangle, which corresponds to cosine. So let's look at the next page. We're gonna write that down in a form that we have it arranged to remember. So cosine at 30 degrees, or pi 6, that's the same angle, is square root 3 over 2, and the sine function value at that angle is 1/2. Now think about that special triangle that we just worked with. One angle was 30, the other is 60. If I look at it the other way, if I switch them, I'm interested in the reciprocal. So I can say, you know what? Then these values switch places. So for the 60, cosine is 1/2 sine of 60 degrees, or pi thirds, is square root 3 over 2. All right, it invites us to go back and complete the chart. Those two shaded in rows that we didn't complete, I encourage you to go back and do that on your own. Let's go ahead and do this exploration number 4 and talk about the trig function values on the quadrantal angles. This discusses the concept of symmetry. This is what we walked through when we did our unit circle together. When you are doing your unit circle, you are always going to refer back to the x-axis. And because of the symmetry our circle has, you only have to remember quadrant 1, the coordinates in quadrant 1. If you can remember how to count off all of your special angles and then remember your coordinates for quadrant 1, for example, if you can remember that for my 30-degree angle, the x is longer than the y, so that means my x coordinate is going to be the square root 3 over 2, and my y coordinate is going to be 1/2. That is going to be true for every angle that is 30 degrees from the x-axis. Well, in quadrant 2, this is the angle that is 30 degrees from the x-axis. So I'm going to use these same coordinates, square root 3 over 2 and 1/2, and then I look and I say, you know what, in quadrant 2, x is negative. Where else do I have an angle that is 30 degrees from the x-axis? Well, right here in quadrant 3, this angle is 30 degrees, oops, right there, 30 degrees from the x-axis. So the coordinates are going to be the same, square root 3 over 2, 1/2. But I'm in quadrant 3, and in quadrant 3, x and y are both negative. Then I move around to quadrant 4, and I say, okay, right here, this angle is 30 degrees from the x-axis. It has that same set of coordinates, but in quadrant 4, x is positive, y is negative. You do that for all of those special angles, so all you have to remember is quadrant 1. All right, let's look at the next page of notes. Here in example 3, we're going to be finding exact values for the trig functions for our multiples of 30 degrees, 45 degrees, and 60 degrees. So what you're being asked to do is figure out, okay, I'm given an angle. What is the reference for that angle? For example, let's start with sine of 5 pi. Well, where would 5 pi fall? If I am rotating around my circle, I go 1 pi, 2 pi, 3 pi, 4 pi, 5 pi falls right here. What's the sine function value of that? Well, it's on the x-axis, so sine is 0 because sine corresponds to the y-coordinate. Okay, what about this one? Cosine of a negative 540 degrees. Negative means I am rotating clockwise instead of counterclockwise. So let's think about this. If I'm rotating clockwise 540 degrees, well, I'm going to head out here and I'm going to go, okay, there's 360, right? What is the difference between 360 and 540? If I do 540 minus 360 and I find that difference, I see that I've still got to go another 180 degrees. So I did a full rotation, I come back, I go halfway around. This is negative 540 degrees. Well, I'm in the same place. But this time I'm asked for the cosine function value, which corresponds to the x-coordinate, which is negative 1 there. Okay, this is a little bit more complex. I'm going to start to do a little bit of arithmetic with my function values. You might want to refer to your unit circle here while you're still getting comfortable with these values. Sine of pi fourths. Well, pi fourth is a 45-degree angle. Sine and cosine are the same. They're both square root 2 over 2. Times the cosine of pi. Well, pi is over here. Cosine is negative 1. Minus the sine function value of 3 pi halves. 3 pi halves is down here. Sine is the y-coordinate. That's going to be a negative 1. So minus a negative 1. Negative square root 2 over 2 minus a negative 1 is plus 1. I need to write this 1 as a fraction with a common denominator so I can add it to this first term. That gives me a negative square root 2 plus 2 over 2. And that's where I stop. That's what it is. Oh, guys, I'm looking at this thinking no, that's right. Sine of pi fourth is square root 2. Negative is positive square root 2 over 2. Square root 2 over 2 times that negative 1. I'm looking at my notes and they were not correct. I'm happy now. Okay. Yeah, because that makes that negative. Sorry, guys. Sometimes the notes that I've done in advance don't even help me out. Let's move to D. Tangent of pi fourths. Now, if you have not filled in your chart, you might not be able to do this right away, except that pi fourth is that 45-degree angle where sine and cosine are the same, and anything over itself is just 1. Times sine at pi 6. Pi 6 is that 30-degree angle. Sine at pi 6 is 1/2. Minus sine at negative pi. Well, negative pi is still over here. Sine is 0 no matter which way I rotate to get there. Times cosine of pi third is 1/2. Cosine of pi third is the same thing as sine of pi 6. So I have 1 times 1/2 minus anything times 0 is 0. So my result is just 1/2. And then my final example down here, secant of pi. Well, secant is the reciprocal of cosine. Cosine at pi is negative 1. So secant at pi, if I flip negative 1, it's still negative 1. Minus cosecant at pi half. Pi half is up here. Cosecant is the reciprocal of sine. Sine is 1, so cosecant is also 1. So I have negative 1 minus 1, which is a negative 2. Next example, use your calculator. Use your calculator to find an approximation of the value of cosine of 15 degrees to 2 decimal places. Well, I'm just going to plug this in, but I've got to be sure I'm in the correct mode. I'm in radian mode right now. If I do cosine of 15 right now, I get one answer. It's negative, but 15 degrees is in quadrant 1, so it should be positive. So I know that can't be right. So I'm going to go in and I'm going to change back to degree mode. And I try it again. Cosine of 15 degrees, there we go. Now it's a positive value. Round it to 2 decimal places. Gives me about 0.97 as the result. B. Use a calculator to find the approximate value of secant 10. Well, is this given to me in degrees or radians? This one's given to me in radians because there's no degree value. Now, I don't have a secant button on my calculator. I need to switch, first of all, to radian mode in my calculator, but I'm going to need to use the reciprocal function value. So secant of 10 is going to be the same thing as 1 over cosine 10. I need to be in radian mode to do this correctly. Radian mode. Secant of 10 is the same thing as 1 over cosine 10 because they are reciprocals. So that's what I'm going to put into my calculator. When I do that, I get out about negative 1.19 when I round it to 2 decimal places. So I'm going to say 1 divided by, and then I'm dividing it by the cosine of 10 radians. I need to make sure I'm in radian mode. There we go. Notice that I do have inverse functions above these. An inverse function is not the same thing as the reciprocal function. That's something very important to make note of. The reciprocal is not the inverse function. that cosine inverse button on your calculator means I'm doing the inverse of the cosine function, which means instead of knowing the angle and looking for the cosine value, I know the cosine value and I'm looking for the angle. It's not the same thing as finding the reciprocal function value. Okay, so let's look at this last page in section 5.2. Everything we've looked at so far has referred to the unit circle, but what if the radius is not 1? What if we're not using the unit circle? Well, if we're not using the unit circle, we just need to remember that r is not 1, therefore sine theta is not just y. What that looks like is this theorem right here. And I'm going to allow you to read this on your own and evaluate that circle. Sine theta, instead of, if I'm not on the unit circle, is going to be y over r. Now, it's still y over r if I'm on the unit circle. It's just that r is 1. Cosine theta is x over r. Tangent theta is y over r over x over r, which simplifies to be y over x. Now, this second line of functions are my reciprocal functions. Sine and cosecant are reciprocals, so this is r over y. Cosine and secant are reciprocals, so this is r over x. Tangent and cotangent are reciprocals, so this is x over y. Now, this is all the same information you were given before. It's just that if I am sticking to the unit circle, r is always 1, and that simplifies easier than if r is something else not 1. Let's do an example of this before we end our video. What if we have an angle whose terminal point is at -3, 3? Let's think about where that would be. If the coordinates are -3, 3, that means my x-coordinate is -3 and my y-coordinate is +3. That means my angle theta is going to terminate in quadrant 2. And I have a point on that angle, I have a point on that angle that falls at the coordinates -3, +3. This is angle theta. I can still form my right triangle here. Now, x is -3, y is +3. X is -3, y is +3. I need to know r. I don't know the radius. If I made this a circle, I don't know what the radius of that circle would be. But I can figure it out using my Pythagorean theorem. Pythagorean theorem says r squared equals x squared plus y squared. So if x is -3 and y is 3, r squared is 9 plus 9, or 18. When I take the square root of both sides, now is r in quadrant 2 going to be positive or negative? Well, r is the measure of the radius. It's going to be positive no matter what. So r is always positive. So when I take the square root of both sides, I'm looking for the positive square root of 18. 18 is 9 times 2, and the square root of 9 is 3. So that simplifies to be 3 square root 2. So there are the values I'm going to use to find my 6 trig functions. Now, my 3 basic trig functions that we usually start with are sine, cosine, and theta. So if we do, or sine, cosine, and theta. Sine theta, cosine theta, and tangent theta. Where sine theta is y over r, so that is going to be a positive 3 over 3 square root 2. When I rationalize that, that simplifies to be square root 2 over 2. Cosine theta is x over r, so that is a -3 over 3 square root 2. When I rationalize that, multiply square root 2 over square root 2, I get a negative square root 2 over 2. Tangent theta is y over x. So I have 3 over negative 3, which is a negative 1. Do these angle measures look familiar to you? This is my special angle, 45 degrees special angle in quadrant 2. So it's 135 degrees, 3 pi fourths. It's just that my circle is not a unit circle. R is not 1. R is 3 square root 2. But when I set up those ratios of x, y, r, they all simplify to the same thing as if my 45 degree angle landed on the unit circle. Okay, so reciprocal function values. Sine and cosecant are reciprocal. Cosine and secant are reciprocal. Tangent and cotangent are reciprocal. Well, the reciprocal, if I flip it, of negative 1 is still a negative 1. What about here? If I flip this, I get just the positive square root 2. Excuse me, negative square root 2. I looked at the wrong row. And this one is a positive square root 2. If you don't see that, if I take this and I say, okay, this is going to be 2 over square root 2, and then I rationalize here, I get 2 square root 2 over 2, and that cancels out. If you didn't see rationalizing this one, 3 over 3 square root 2, I rationalize by multiplying square root 2 over itself, multiplying by a well-chosen 1. I get 3 times 2 in my denominator. That cancels out and leaves me with square root 2 over 2. So that's the side work that I didn't show working through it.